In this video, we're going to look at how to identify whether a chemical reaction or chemical change has occurred. When you learn the difference between chemical and physical changes, you learned that any change that occurs to the chemical structure of a substance means that a chemical change has occurred, but we never actually talked about what this means. Well, in order to understand what it means, we can actually take a look at a fairly simple chemical reaction here. So even if you don't know how to read chemical formulas, we can describe what's going on here. This chemical, CH3COOH, is actually the chemical formula for vinegar, which is a type of acid that is used in cooking in order to make certain foods sour, and we know that H2O is water. Now, even if you don't know how to read chemical structures yet, we can still talk about what different parts of a chemical structure mean. So if we look at the letters that make up the chemical structure of vinegar, each of these letters represents the different elements that make up the compound. So O is an oxygen, C is carbon, and H is hydrogen. But what about these lines that are connecting each of the elements together? Well, each of these lines represents what we call a chemical bond, which is a force that anchors two elements together so that they hold themselves together in order to make a compound. And as we can see, when we go from the reactants, what we start with, to the products that we end with, we see that the bond structure changes. So if we look at the structure of vinegar when it's a reactant before the chemical reaction happens, and look at it after, specifically if we look at this part here, we can see that there is a bond that connects this oxygen and this hydrogen, but we can see that this bond here is gone. So we can say that the bond between hydrogen and oxygen has broken, meaning that it was there, but in the chemical reaction, it is no longer there because we broke it and reformed it somewhere else. Well, where exactly did this bond go? If we look at water before the reaction happened, we see that there are two bonds that hold oxygen and hydrogen together, but whereas in the products, we actually see that there are three. So here, this weird-looking form of water, H3O+, has a new bond that is made in between hydrogen and oxygen that wasn't there before. So what we can see from looking at the structures of the reactants and the products in this chemical reaction, we can see that we have either we have made a new bond, or we have broken a bond that used to be there. And whenever this happens, that means that the chemical structure of one or both of the compounds or elements in the reaction has changed from the reactants to the products. There's just one problem with this definition. Can you see atoms, and can you see the bonds that hold them together? Well, the obvious answer to this is no. So if you can't see bonds that break, and if you can't see whether a new bond has been made, how do you know that a chemical reaction has happened? Well, you can't by looking at the bonds, so instead we have to look for any differences we can see that indicate that a new product has been formed, and there are 5 clear ways that we can see that this happens. The first and most obvious way is to look for a color change that indicates that a product has a different color than the original reactants. So in this reaction here, we can see that the two reactants that we're mixing together, AgNO3 and NaCl, are both colorless. These are both compounds that are dissolved in water, and each of them doesn't have a color because the solutions that we mix together are both colorless. But we can see when the products form, one of these products, in this case AgCl, forms a white powder within the liquid like this. And there are a bunch of very cool colored combinations that you can get that involve forming powders that don't dissolve in water. Now, if there's a color change, usually this is accompanied by another obvious change where mixing two solutions together results in a solid that is being formed that is insoluble or doesn't dissolve in water. And this is what we call a precipitate. So a precipitate is simply a solid that forms within some sort of solution when more than one solution are mixed together, and because the precipitate does not dissolve, we see that it is clearly visible. Now, what happens if we start seeing these? Well, if we look in the bottom of this test tube here, you can clearly see at the bottom that there are bubbles that are being formed. Now, if you get bubbles that form within a liquid, that indicates that a new gas molecule has been formed. So if we look at the reactants here, the S here indicates that we're dealing with a solid, and AQ indicates that we're dealing with some sort of dissolved compound. But if we look in the products, we can see this G here indicates that we've made a new gas, in this case, hydrogen gas. And because these bubbles were not here before, because there was no gas in the reactants, this hydrogen here is new, meaning that a chemical reaction has occurred. But the most exciting observation that we can make, or at least to me, is a change in energy. Now, a change in energy is very broad, but when we refer to a change in energy, usually this means that you're going to observe some sort of heat that is either released or consumed by the reaction. You might also see energy in the form of light that is produced, or you might hear a very violent or explosive sound that occurs when a small explosion has taken place. So in these two reactions here, this reaction shows what happens when we burn a very reactive metal called magnesium in oxygen in the air. We get this very, very, very bright white light. And this is so bright, looking into it for too long a time can actually cause you to go blind. And this bright light is actually what's used in fireworks. Then if we look at the production of water, hydrogen and oxygen are both very explosive gases. When they react with one another, the energy that they release is released as heat. And again, this will look like a flame that appears very, very brightly until all the hydrogen is gone. So this is why I said that a change in energy are often the most exciting reactions to behold, because again, this energy that is released by the reaction was not originally there before, indicating that a chemical reaction has taken place. And finally, this is very important to perfume makers or to anyone that wants to work in the fashion industry, because the presence of a new smell is very often an indication that a new chemical has been made. So this is particularly common among organic compounds. And if you don't remember what organic compounds are, an organic compound is a family of compounds that all contain, let's spell contain properly, carbon-containing compounds are examples of organic compounds, and many of these compounds will have very distinctive scents. All perfumes, or pretty much all perfumes, are organic containing compounds. But for a more simple example here, this here is the alcohol that you find in beer, wine, vodka, or any consumable alcoholic beverage, which again has a very distinctive smell that neither of our reactants do. So the presence of this scent that was not there before indicates that we have made a new chemical, which is usually some sort of organic compound. This concludes our video series on properties of matter to test whether you know how to recognize the difference between a chemical change and a physical change, and what observations qualitatively and quantitatively you can make to identify whether a chemical change has happened. Check out the practice problems below, and in the next series of videos we're going to look in more detail about what elements are and the structures of elements that occur in chemistry.